this video, we are taking a look at questions 24 through 27 in Section 4 of SAT Practice Test 1. So let's start with question 24. And if we look here, the question reads, which of the following is an equation of a circle in the xy plane with center 0, 4, and a radius with endpoint 4/3, 5? Okay, so first things first, for this kind of question, we have to know the standard form for the equation of a circle. And that is going to be x minus h quantity squared plus y minus k quantity squared equals r squared, where hk represents the center of the circle and r is the radius. So that's our key background content that we just have to memorize for a question like this. And if we do have that memorized, then this actually becomes a question that we can answer very quickly and easily. If we don't have that memorized, you could try plugging in some points and testing out a few of the answer choices, try to see what works, maybe use distance formula to try to find that radius given the center and the endpoint. But it's going to be a lot of extremely complicated math, and frankly, in an SAT context, not math that we're going to have the time to do on test day. So make sure you get this standard form for the equation of a circle memorized, and then let's see how that is going to be put into action on a question like this. So first of all, our value for hk for the center would match up to the 0 and the 4 that we see here, which means that when you have x minus h, that's like saying x minus 0, so that first part of your equation would just be x squared, which we see in all 4 of our answer choices, so that by itself doesn't help us eliminate anything. But let's take a look at the next piece, y minus k. So that next piece should be y minus 4 quantity squared. So we're going to have an x squared and then plus y minus 4 quantity squared. And that allows us to eliminate answer choice B and answer choice D on this. Now we want to take a look at what it's equal to. And it says that it's equal to r squared. So we could take the time to solve for r using distance formula, and we could then square that value. But if we look at the relationship between what we see in answer choice A and answer choice C, we can see here that you have 25/9 and you have 5/3. And if we're thinking like a savvy test taker and understanding the kinds of mistakes that the test makers might be expecting a student to make. So here, this is likely going to be r and r squared, because that's a very common test taker mistake, that a lot of times test takers forget to square the value of r. They go through all the hard work of finding it, but forget to square it. And if we can recognize that this number, 25/9, is 5/3 squared, we can see the relationship between those two answer choices and go ahead and select answer choice A, again, without having to take the time and without having to deal with the complex math involved in finding the radius by using the center and the endpoint and having to do a very complicated distance formula on a question like this. So that's the ideal approach on question 24. And our correct answer choice there is A. Now let's move ahead to question 25. On this one, they give us an equation which says h equals negative 4.9 t squared plus 25t. And the question reads, the equation above expresses the appropriate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? So this is going to have two variables, h for height and t for time. And in the question, the way it's phrased, part of the reason this is question number 25 out of 30, meaning it's supposed to be a pretty difficult question, it's because to solve for one variable, that means that we have to be able to plug in a number for the other, and we can plug in a number here. It might be hard to recognize, but we can plug in a number here. So in this last sentence where they say after approximately how many seconds will the ball hit the ground, is there anything in there that gives us a value for one of those variables? And hopefully when reading that, you say to yourself, oh, right here, this is the key phrase, when the ball hits the ground. So if the ball hits the ground, that means that your height at that point is going to be 0. So when the ball hits the ground, that is the way that they sneak in that numerical value for height. Height is 0, and now we're going to plug that in and solve this equation. And so here we have 0 equals negative 4.9 t squared plus 25 t. And in this case, we can factor out a t and set up two factors. So here we would have t times negative 4.9t plus 25. And you can set either factor equal to 0. We have a t equals 0 because that is a place where the height is 0. That would be at the very beginning. So if we are throwing our ball up into the air and then it's returning back to the ground. So here you would have a t equals 0 at this point, right when you go to throw that ball up initially, and then when it returns from being launched vertically. So this is going to be our second value of t. Here is the one that they're actually going to be looking for, and that's what we'll get from this factor, negative 4.9t plus 25 equals 0. And we can solve for that. We get 4.9t when we bring that over to the other side equals 25. And we can divide by 4.9. You could plug that into a calculator, but we don't have to in this case because the question does say approximately. So if your answer choice is going to be rounded, then you can round here to make this math easier. 25 divided by 5 would be 5. And so t will approximately be 5 seconds for when that ball will hit the ground. Up next, let's take a look at question 26. In this one, it says, Katerina is a botanist studying the production of pears by two types of pear trees. She noticed that type A trees produced 20% more pears than type B trees did. Based on Katerina's observation, if the type A trees produced 144 pears, how many pears did the type B trees produce? So we could, in this, check and do 20% of each of our answer choices here, and then add that on to see what comes out to be 144. So if that is a possibility, and you can use your calculator to do that, then you could go through each answer choice that way. So here you could do, all right, 115 times 0.20, and do the math on that. So that would come out to be 23. And then you could do 115 plus 23 and check and see if it's equal to 144. In this case, that would be 138, which is not equal to 144. So you'd say, no, thank you. Next question. You could do that for each of those and on down for answer choices B, C, and D. So that's correct math. So that is doable, but let's see if we can look at a more efficient way to approach this same question. So here, remember what we talked about in section 3. And if you haven't watched those explanations, then it might be worth going back to look. But in section 3 of this same practice test, we talked about when you have a percent change, different ways that you can approach it, more efficient ways that you can approach it. And there's one question early in section 4 where we look at the same technique. And that is when you have a percent change, you can look at that percent change relative to 100. So 20% more would be an increase of 20%, which means that you're looking at now 120% of your original value. And 120%, or as a decimal, that's like saying 1.2, that would be your multiplier that should give you your new value, your end result. So here your multiplier times each of these would be 1.2. That'll save us a lot of time because for these answer choices here, you could set it up as an equation. Type A produced 20% more than type B, which means that type A would be equal to 1.2 B. And you could plug in 144 for A and solve. And that would give us 120 is equal to type B, which is answer choice B on this. Or you could simply take each answer choice and multiply it by 1.2 and check to see whether or not it's equal to 144. This one, as we know, came out to 138. This one, when you plug it in, it does in fact give you 144, and you're done. And then the other answer choices would be over. So you can run through and multiply everything by 1.2, or you can set up an equation like we see down here. So either way is absolutely fine on question 26. The key takeaway there is this concept of making sure that when you have a percent change, we understand how we can view that as a one-step calculation to save us some time on test day. And now our last question from this set, question 27, which is kind of a long one, so let's read through it quickly here. It says a square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is a square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? Okay, so if we look here, we have these 10 regions, but let's do a visual representation of what these regions represent. So here, if we have a square field, so I'll do my best to make a square, and this is broken up into, it says the field itself is 10 meters by 10 meters, but each of these regions that they're talking about are 1 meter by 1 meter. So you're looking at here, if this is 10 meters by 10 meters, each of these is just 1 by 1. So it's a tiny little portion of our entire field. And if we calculate our total, so here, if each section that we have represented in the table is 1 square meter, our entire field is 100 square meters. So each of these is only 1/100th of our total. Our entire field would be 100 times the number of earthworms in each region that we have in our table. So that means for the entire field, we would be, if we multiply each of these by 100, somewhere between 10,700 and maybe 16,600. And you could again calculate an exact average here to be able to multiply it out by 100 for the entire field. But by looking at our answer choices, what do they all have in common? So they all have this 1/5, right? So we know that that's going to be numerically the number that we're working with. We just have to figure out how many zeros on it. So here, if we were to average out these numbers, this is going to come out as an average for each of these regions to approximately 150. And the most important thing, and we'll switch colors here just to really emphasize it, but this value is representative of the average number of earthworms in just one of these little squares. Now for the entire field, we have to multiply that value times 100. So here we have 150 times 100, which would give us an approximate value of 15,000 for the field as a whole, which would match up with answer choice C. So just make sure here that you're really careful on this. A lot of times what I see test takers do is they take this table, they average out those values for the region, they get 150, and then they pick answer choice A. They pick 150 because that's the first number that they see in a calculation that they've done, but it's not going to be answer choice A here because we have to read the question and the setup carefully to know the relationship of the information in the table to the field as a whole. Up next, we'll take a look at our last few questions.